Welcome to the ET322 how-to video for Lab 3 Rectifier Lab. This one's a short version with a completed multi-sim. I will do another video which shows you how to build the multi-sim circuits. The first thing I built here is our transformer and AC circuit without any of the diodes. So what I have here is an AC signal, 120 volts RMS. And you see here with our DMMs, the DMMs measure when they're doing the AC, they are measuring RMS. And our output will be 12. Here we have a 10 to 1. That means ratios is 10 to 1, which means our voltage is going to be decreased by a factor of 10, which it is, 120 versus 12. Okay, and if we go down here, we can look at our oscilloscope. So it's a sine wave coming and going, 119 volts RMS coming in, 12 volts RMS coming out. But what you notice here is on the oscilloscope, it's reading 338 volts peak to peak. RMS is an average of that sine wave, but if you look at it on the oscilloscope, it's going to be 338 volts. Okay, even peak is 169, so that's quite a bit of voltage coming in, and this pretty much shows everything we need for just the transformer circuit. Here I'm showing a half wave rectifier circuit. I have one diode, and you see here that we have the yellow is the input and the cyan or the blue is the output. So let's turn off yellow, and you see here is the half wave output. It's missing the bottom alternation there, and this is the typical output of a half wave rectifier. Here I'm showing a full wave rectifier. The difference is that we have a center tap because we need a ground reference. Unfortunately, this one will cut the voltage in half, and we have two diodes and they go into the same place. That allows us to take that sine alternation and flip it and make it positive. And let's go ahead, and you see the sine wave going in, and you see the half wave coming out. Being that we filled this center section up, it's going to help us to filter that. Here I'm showing the full wave bridge rectifier, and you see we have the same pattern as the other full wave, except this one's going to give us full voltage out. So a bridge diode setup has 4 diodes, and they're set up in a bridge setup, and this is the typical way that you'll see a linear power supply now. And those 4 diodes now come into a little IC package and other forms, which make these very easy to make.